I've been driving
Welcome back
down
to Vibe
this back
Podcast.
road,
Today we're
chasing
discussing
my
milliseconds
mistakes,
before the Charlie Kirk shooting
trying to
event, a
find
topic researched for us by
redemption
David
in
Morgan.
the choices.
I'm joined by Charles and Angela.
Hi everyone, I'm Charles, and I'm looking forward to breaking down some pretty cool science into bite-sized pieces so we can all understand what's really going on here.
And I'm Angela, an expert in modern spatiotemporal motion analysis. I'm excited to share how our understanding of movement and perception can shed light on these fascinating events.
Excellent. So, to set the scene, David's research focuses on an event at Utah Valley University on September 10, 2025, specifically around a Charlie Kirk appearance. The live broadcast from Bartholomew shows a buzzing crowd, a mix of students and adults, some protesters with banners. Initially, no signs of aggression, just expressive protest. But then, things change quickly.
That's right, Alice. The recording hits timestamp 12:23, and suddenly, you hear a gunshot. What follows is exactly what you'd expect. Instant crowd panic. People scattering, crouching, taking defensive postures. It's a classic example of acute threat perception.
It certainly is. The sudden shift in collective body kinematics is a textbook response to an unexpected perceived threat. Our bodies are wired for that immediate self-preservation.
But here's where it gets really intriguing, according to David's findings. In the moments before that 12:23 mark, a young woman wearing a rucksack is observed. And she raises her hands in a defensive or startled posture. Charles, why is the timing of her reaction so critical?
This is the really wild part, Alice. Her reaction, raising her hands, seems to happen about 100 milliseconds before the sound of the gunshot actually hits the microphone. Think about that for a second. It's super fast, like a blink of an eye.
100 milliseconds. Angela, from a neurophysiological standpoint, what does that timing tell us?
That timing is absolutely significant, Alice. A classic startle or fear reflex, like raising your hands, shrugging your shoulders, or pulling your head back, is incredibly fast. These are primarily processed by subcortical pathways in the brain, involving structures like the amygdala and brainstem. They bypass the slower, more conscious cortical processing. This allows for reactions within a time frame of 70 to 150 milliseconds of a stimulus. It's similar to how quickly you'd react if a spider suddenly dropped in front of your face. It's an involuntary, almost automatic response.
So, it's not like she thought about it and decided to raise her hands. It's automatic, a reflex.
Some might jump to conclusions, perhaps even suggesting precognition, that she reacted to something that hadn't even happened yet. Charles, what does science say about that?
That's a great question, Alice, and one that often comes up in these kinds of discussions. From a scientific perspective, precognition just isn't a tenable explanation. Humans don't react to future stimuli. It simply doesn't align with what we know about human perception. Instead, this timing strongly implies she reacted to a different sensory cue that occurred before the gunshot itself. Something else triggered her.
Exactly. Our brains are remarkable, but they operate within the constraints of physics and biology. Reacting to a future event is outside those parameters.
And what about the acoustics? Could she have simply heard the gunshot earlier than the microphone?
No, that's where physics steps in. Sound travels through air at about 343 meters per second. So, if everyone's roughly the same distance from the sound source, they're going to hear it at basically the same time. If someone claimed she heard the gunshot 100 milliseconds before others, she'd have to be significantly closer to the source than everyone else, which the video doesn't indicate at all. That would violate basic physical principles.
The physics of sound propagation are quite clear on this point. Unless she was practically at the muzzle of the weapon, which the visual evidence does not support, an auditory pre-reaction is physically impossible.
So, if it wasn't precognition and it wasn't that she heard the gunshot earlier, we're left with the conclusion that her reaction was visually or peripherally triggered. Charles, any initial speculative explanations that come to mind?
Well, one thought people might have is that she saw a muzzle flash. Like the flash of a gun firing. But David's research points out that in a bright, noisy environment, with tons of cameras and phones flashing all over the place, a quick muzzle flash alone might not reliably trigger that kind of fear reflex unless she already had a reason to expect a weapon discharge. It's hard for just a quick flash to stand out among all the visual noise.
That makes sense. Angela, what other plausible explanations does your field offer, particularly regarding motion-based threat detection?
This is a key area where spatiotemporal analysis is crucial. The human visual system is incredibly sensitive to sudden movement, especially in our peripheral vision or in overhead spaces. One very plausible hypothesis is that a bird exited a dark recess beneath the Sorensen roof hearing the gunshot 100 milliseconds before the woman with a rucksack. Sudden rapid movement from shadowed architectural spaces is a well-documented startle stimulus. If the individual happened to be looking in that general direction, even peripherally, such a sudden, unexpected movement might very readily trigger that defensive reflex we observed.
So, her brain sees something fast and unexpected darting out of a shadow, and it tells her, danger. Hands up, even if it's just a pigeon. Our brains are designed to be quick on the draw when it comes to potential threats, right?
Precisely, Charles. And to add another layer, there's the concept of misidentification. In conditions that aren't perfectly clear, like the potentially low-light areas beneath a roofline, the brain often fills in missing visual information. A bird suddenly emerging from darkness might, for a split second, be perceived as something like a bat. Bats, due to evolutionary threat associations, often elicit fear reactions. The amygdala, that rapid response center in our brain, reacts to such ambiguous stimuli very quickly and non-verbally, often before we even consciously recognize what we've seen.
That's fascinating, that our brain can react before we even know what we're reacting to. Angela, how can modern technology help us understand these complex reactions?
This is exactly what my field specializes in. Modern spatiotemporal motion analysis software allows us to precisely evaluate such rapid reactions. We can map body kinematics, how the body moves, alongside gaze direction and crowd movement vectors. By doing so, analysts can estimate the likely origin point and nature of the stimulus that triggered the reflex. These tools are incredibly valuable. They're commonly used in forensic video analysis to distinguish whether a reaction was primarily caused by sound, light, or motion, allowing us to reconstruct the event with a high degree of scientific accuracy.
So, you can basically reverse engineer the event using all the data, and figure out what most likely happened based on the science, instead of just guessing. That's really cool.
That's the goal, Charles. It brings scientific rigor to what might otherwise appear to be ambiguous observations.
This has been a truly eye-opening discussion. So, to summarize, David Morgan's research suggests that the young woman's reaction does not imply any kind of foreknowledge of the gunshot. Instead, it's consistent with a very fast, sub-second fear reflex, likely triggered by a visual or motion-based stimulus that occurred just before the shot.
Absolutely. Science strongly supports the idea that she reacted to something she saw, not something she heard, and definitely not something that hadn't happened yet. Our brains are just incredibly wired for fast threat detection, even if it's just a bird startling us.
That's all for today. A big thank you to our guest researcher, David Morgan, for providing our topic.
I've been driving down this back road, chasing my mistakes, trying to find redemption in the choices that I make. Every mile reminds me of the love I couldn't hold. Every scar's a story, every tear's a piece of gold. And I swore